All right. So vocabulary words. Yeah. A monomial. Anything where you have a number times x to a power is what I really want to. There's a little bit more to the word monomial than that, but that's what I need you to focus on right now. So I have some examples for you to write in. And here are some examples of monomial terms that we are going to be looking at as we do polynomials. So 2x, negative 3x to the fifth, x squared, negative 8x cubed. 5. Numbers themselves are actually polynomial, with the exception of 0. But that's a special case that you don't probably ever need to worry about. Wait, are the Chromebooks specific? They are the Chromebooks. They ordered over 13,000 Chromebooks for every single student and teacher in the district. But they ordered them mid-August. I don't think I need to explain any further. Wait, the worst one of them all 5? What are you talking about? I don't know what you're talking about. Oh, sarcasm. Okay. Oh, no. Every single student in the district will receive a Chromebook. The problem is, I don't know if they've gotten them or not. They're not really telling us to. I shouldn't be recording me explaining this. Okay, let me put on my positive side. They ordered them for you. Yeah. And once they do receive the shipment, I don't know if they've received it yet or not, they have to open up all 13,000 plus boxes, put everything in that they want, code them, because, you know, it's going to take a while. Anyway, monomials. Back to monomials. Okay. So a polynomial. A polynomial is just taking a bunch of monomials and adding them together. So what I did was I made some polynomials out of those monomials. So some examples. I agree 100%. Yes. Yes. To that comment online. Oh, big time. Yeah. So yes, 5 is a polynomial. Any number other than 0, but I'm not taking you there, is itself considered a polynomial. Now, I've got polynomial 2x plus 5 made up of 2 monomials. The next polynomial, 3x to the fifth minus 9x to the fourth plus 20x plus 5x cubed, 4 monomials put together. And then polynomial x squared minus 5x minus 1, 3 monomials. Negative 8x cubed plus 9 minus x to the 6th. Why is that one all out of order? And then plain 5. Why? Because that's how many fingers we have. All right, moving on. If you need a little bit of time. So how is 5 a polynomial? It's when people define things in math, those are the human choices of math. And I think it's really important that you understand that every definition you run into is something that a human chose to attach onto a thought. And decided that this is what they're going to mean when they use this word. The logic then can take over and the real math starts. But people had to make a vocabulary and some way of communicating the logic that comes about. But they decided polynomials would include just plain old numbers. Do you mean the exponent, n? That is a very good question. To be a polynomial, the exponent cannot be a negative number. It cannot be a fraction or a decimal. It must be a whole number. And did I say that over there? Yes, I did. N represents whole numbers. It could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So I started with a monomial, and then a polynomial is just any addition, subtraction of a bunch of monomials. And while it may seem weird to put a 0 as an exponent, let me talk about that for a moment. If I said x to the power of 0, what would you tell me? That's right. You would tell me 1. So 5 itself is actually the polynomial 5 times x to the 0 power. It's just not emphasized very much. And I think a lot of people, even in higher level math, aren't aware of this. And I'm going to come back to this also as I talk about some other vocabulary words. So then the next thing is you need to understand what I mean when I say a term. And I've actually been using the word term throughout the class. It's anything in between addition, subtraction signs. So it's basically those monomials. But when we talk about, when I have subtraction, like right here I have minus 9x to the 4th. When I talk about the terms, that subtraction needs to be included. So that term is actually negative 9x to the 4th. Terms are really separated by addition. And it's the monomials that we put together to make the polynomial that are the terms. Now, if you are typing this, see, here was the fun thing about being able to use the computer on these. I was able to do copy paste and then just backspace and put commas for every plus sign. And it saved me time from having to sit here and write a list of each of these terms. And I don't know where you guys are at, which is why that ClassKick thing could be beneficial. I could see actually where everyone is at, if I can find it. I know you guys don't want me sharing anything you have, but I just want to see. Did some of you just download it and you're just not using it? Looks like it. Is anyone actually using it and trying it? Okay. Then I'm going to keep going. If you need me to slow down, tell me. Okay. Okay. I'll have it ready on ClassKick tomorrow, and because I want someone to try it out to find out if it's worth it. Otherwise, I'm not going to sit around and bug the whole class to change to ClassKick. But apparently there's a lot of good stuff in there that I haven't even started to look at. All right. Now, so we just talked about what a term was. You need to know what it means when I say the constant term of the polynomial. So 2x plus 5. The term that does not have an x in it is 5. That's the constant term. But the next polynomial does not have a term without an x multiplied in there. Therefore, we understand that technically there's plus 0 sitting on the side. And if we need to talk about the constant term of that polynomial, we will say 0 is its constant term, even though we don't see it. Then for the third one, I have a minus 1, but that entire negative with the 1 is considered the constant term. Now, that oddly arranged polynomial, the constant term is 9. It's just written in the middle of everything. And then if your polynomial is just a number, then that number is the constant term. What if there are if there are multiple constant terms, then you have to add them together, and their sum is the constant term. And the reason each of these are getting vocabulary words are because they hold an importance with things we're going to be learning. And you need to know what the constant term is. And actually, I can tell you now, one of the big things about constant term is it is the y-intercept of the graph of the polynomial every time. All right, I'm going to keep moving. Again, tell me in chat if I move too quickly. Coefficient, you need to know this word, coefficient. And I often get very tired of people don't tend to know what coefficient means, and they'll write a term instead of a coefficient. A coefficient is just a number, and it's whatever number is multiplying to the variable. So with 2x plus 5, it has coefficient 2, but the constant term is also considered a coefficient. Although some of the new Common Core curriculum is not mentioning the constant terms being the coefficient, but it is. That is the official math thing. The next polynomial, our coefficients are 3, -9, 20, and 5. Now, if you don't see a number in front, so if you're with me right now, you're looking at this x squared, we understand that that x squared is multiplied by a 1, even though we don't see the 1 being multiplied to it. So if you don't have a number in front of it, know that the coefficient is 1. So I've got coefficients 1, -5, and then also -1. For the next one, I have coefficients -8, 9, and -1. And just to point out, if you see minus and then just x to a power, that minus goes with the coefficient, and then having no number written there, we understand it to be a 1. So that coefficient of x to the 6th is -1. Then 5, what is its coefficient? I'm 5. Yep, yeah, it is. Okay, now, I talked about the constant term, and the constant term plays some important roles. Very important roles are played by the leading coefficient. So you just found out what a coefficient was. Only one of them is considered the one who leads. And it is the coefficient of the term that has the largest exponent. So with 2x plus 5, technically, I have x to the 1 power multiplied to the 2, And 5 is technically multiplied by x to the 0 power. So as far as being the coefficient of the term with the largest exponent, that x to the 1 is the largest exponent. Then here, 5 is the largest exponent. Therefore, the coefficient 3 is the leading coefficient. What spooky arithmetics. Okay, I don't even know what to say. Oh, by the way, I need to upload that. I'm trying to remember all these different things to do for this class and then for the other class, and sometimes I forget. We will be having a test on polynomials the last day of quarter 1. And I can't remember which day that is, but it's right around Halloween time. Not that we're going to have a trick-or-treat version of Halloween. But anyway. All right. For the third polynomial, do you see that the leading coefficient would be that understood 1 in front of the largest exponent, x squared? Yes, this unit is just about polynomials. And if you talk with other Math 3 people, they probably just finished polynomials. But I'm taking out units that are absolutely unnecessary for you to do, because if I can't find a lesson on Khan Academy that uses it and I can't find it in the Common Core state standards, it's not necessary. So moving on. On the next polynomial, the largest exponent is this 6. So -1 is the leading coefficient. And then when it comes to 5, hey, if it's all you got, it's all you got. So 5 is considered the leading coefficient. All right, degree. This word is going to be used a lot. The degree of the polynomial is the actual exponent number that is the largest exponent of the polynomial terms. So, going back to what I said earlier about the fact that even though I don't see an exponent 1, that 2x has an exponent 1 on the x. And technically, if you want to say it, 5 is 5 times x to the 0 power. The degree is this largest exponent, number 1. For the next polynomial, the largest number that I see in an exponent is this 5. For the next polynomial, the largest exponent I see is this 2. For the next one, even though they're kind of in a different order, 6 is the largest exponent. That is a degree 6 polynomial. And if you see a number who's just sitting there by itself going, it is a polynomial that is considered to be degree 0, because it is the same thing as the number multiplied by x to the 0 power. So 0 is the largest exponent on an x in that polynomial. All right. Now, you've heard some of these words. Maybe you've heard all of them before. Well, actually, in a way, 5 made it to every party. Okay. So, when we are looking at a polynomial that is just a number, it is degree 0, and we call it a constant polynomial. You're familiar with the word linear function. When a polynomial is degree 1, it is linear, and the word linear means of a line, so line. If it's degree 2, we've already used the word quadratic. An example of degree 2. Degree 3, we call a cubic polynomial, and you've heard that word before. There's an example. And not said too often, but a degree 4 polynomial is called quartic. And I swear, every time I see that word, I think of, which one was it? Deep Space Nine? That had Quark. Yeah. Anyway. So there we go. Quartic. And oh, what? No one likes Star Trek anymore. Oh, knife in the heart. I am not the only one. Ah, Star Trek. Please tell me you've at least heard of Spock. Live long and prosper. I'm going to move on. I'm moving on. Okay, so directions for problems. Okay, I'll very much agree with that. Standard form of a polynomial is one that is written in descending order of the degrees. A lot of the polynomials, the way I presented them was standard form, but know that often directions to a problem will say to write this polynomial in standard form. Sometimes standard form is also referred to as expanded, as to be different from being factored. We are going to be factoring our polynomials. Who's looking forward to factoring their polynomials? You factored quadratic polynomials. We're going further. Okay, so as far as standard form of the polynomial, all I have here is that I have rewritten things. Oh, that's right. I highlighted the things that had changed. I was about to erase my highlight, but then I remembered I actually highlighted it for the answered document to point out that 1, 3, and 5 did not need to change. They were already written in standard form. And I highlighted whoever needed to move. So by moving 5x to the third power to this position, it was put it in standard form. Okay, Christopher, what? I remember this from my old school, and okay, whatever. Anyway, x to the negative x to the 6 had to move in front, and there you go, standard form. Now, also, you're not going to have to get too deep into this right here, okay? But I just want to introduce you to, this is the way to write a generic polynomial function. Okay. In a generic polynomial function, we say that it's degree n, and we have the coefficients as some letter. It's typically A, B, or C with subnumbers written down. So these subnumbers aren't exponents at all. All they are saying, I'm distinguishing myself from the other coefficients of this polynomial. Okay, do you ever try to say something but fail to articulate yourself properly? Every day. Anyway, so basically it allows for a really nice matchup also to say like a sub 2 is the coefficient for x squared. Anyway, I'm not going to be forcing this on you, but if you go on to a next, if you go on to a pre-calculus or intro to calculus class, you will have that thrust upon you to have to deal with it. All right, moving forward. Now we've got examples. I'm going to go where you can't see the answers. Whoa, stop. Okay. Now, you need to figure out which ones are polynomials and which ones are not. And for you to get to not have to write as much, you're just going to write the letter, and I bold printed the letters to help emphasize. Just put the letter. We've got A, B, C, D, E, F, G, H, I, J, K, L. And I want you to first just list which ones are polynomial, which ones are not polynomials, and then we'll look at why each one that isn't. So take a look at that, and this would be a fantastic time for you to be in groups working on this, but I am terrified to put, I don't know if I'm ever going to use breakout rooms. I'm scared now. But I think the problem was that I left the main room, and I guess I can't leave the main room. It just does bad things, like kicks half of you out, and the other half are stuck having to be here while the other half are going, but I can't get in. And the half inner, I can't get out. Oh, that's an Indiana Jones reference. Let me in. Let us out. Anyone? No. They were in the spiky cage. The spikes were coming out. Okay. Thank you. Thank you for someone understanding. I believe that is the one with the heart that gets ripped out. Yeah. All right. So moving along. Have you taken the time to figure out which ones you believe to be polynomials? So let's see. Do you believe A is a polynomial? Correct. Yes. And I'm just going to show the answers in a moment. Do you believe B to be a polynomial? Yes, B is a polynomial. What about C? C is not a polynomial because you have root x. Root x is x to the 1/2 power. The exponents are only allowed to be 0, 1, 2, 3, 4, 5. It's out. What about D? Do you think D is a polynomial? Correct, it is not. So I'm going to blue the polynomials, or the non-polynomials, I mean. And the problem is not, if you simplify this, you have to divide x to the 4th by x, and then you have to divide the 1 by x. And that is going to create something very non-polynomial. But further than that, let me ask you this. Can you plug 0 into that x? Are you allowed to put 0 into that x? You are not. It makes a division by 0. Polynomials are friendly functions with a domain of all real numbers. They love everybody. They're inclusive. This is actually a fraction of 2 polynomials, and that's called a rational function, which, guess what? It's the next unit after this one. Woo! But until then, we just get friendly polynomials. Then, do you think E is a polynomial? Yes, it is. Now, F is trying to trick you. F is trying to trick you. Root 3 is a coefficient. And coefficients are allowed to be any real number. The exponents have to be whole numbers, but the coefficients can be anything. So F actually is a polynomial. So it gets yellow highlight. Now, please tell me you know G is not polynomial. Because we've been playing with it quite a bit. It is an exponential function and it is not polynomial. And what you want to recognize is the variable is the exponent. That does not happen with polynomials. Polynomials only have numbers for exponents, whole numbers. Is H polynomial? And you said yes. Yes, it is. Is I polynomial? No, very good. Because, whoops, wrong color. Because it has a fractional exponent, 2/3. Exponents must be whole numbers. J, polynomial? Yes. K, polynomial? No. It has the variable in the spot of the exponent. That makes it an exponential function, not a polynomial. Polynomial never has the variable in the exponent. And lastly, I guess someone just had to throw a log onto the L. Yeah, no, that's not polynomial. So I've got, why did it go back to the very beginning? Why didn't it leave where I left it? I don't know why. But here are the answers if you need to see that. And then, let's see, what else? Fill in the information. So you do have access to this document. I uploaded it, I believe, before class, so you can see it later. All right. So for each polynomial in the previous problem. Now, here's the thing. I don't want you to pain yourself. Okay, so the polynomials that we had were, and I'm going to have to write it down here so I can see it, A, B, E, F, H, and J. A, B, E, F, and J. J. Anyway, these are the polynomials. And I don't know if you've taken the time to write them down or not. I know it's kind of a pain to have to write it all down. On the homework, I have the polynomials written already. And know that this is just making sure you've got the new vocabulary words. H, yes. I can't, wait, A, B, E, F, H, J. Apparent, what? Okay, maybe I should show you the answers that are typed. Apparently, I did not write down H, and I don't know why. I just didn't. I guess I didn't like it. Oh, you know why? Because H stands for hot, and I hate the hot weather. Don't like this hot weather at all. Do you realize how hot it was yesterday? It was horrible. Oh, there's another H word that goes with hot. Horrible. Okay. So basically, know that I'm just wanting to make sure that you understand the vocabulary words. This is a little bit tedious and possibly painful, but it'll prep you for your homework so that you understand what I'm asking for with the homework problems. And then I'm trying to remember. I know, okay, it's not possibly painful. It is painful. I know. So let me see what else. Oh, yes, factoring. Yes. I am videotaping the lesson right now. And on top of it, these answers were recently posted to your Google Classroom. I posted them during third period after I got first and second period taken care of. It always feels like a mad race trying to get everything done to help you guys while you don't have the same environment that you usually do with learning. I'm understanding that there's some emergency board meeting coming up because people want something for Q2. Anyway, moving on. Oh, today. Okay. The one thing I'm hoping, I do not want to be forced to go to the classroom and be by myself in a classroom. Do you know how depressing that is? At least here I've got my doggy. But if I'm going to go to the classroom, I better be talking to people and not sitting by myself. Actually, I was thinking that if they make us go, I'm going to ask the administration if I can bring my dog. Because he can't handle being without me anymore. Anyway, okay. Oh, I'm showing you the answers. I wanted to not show you the answers, but start off with the questions. Okay, first rule of factoring. You've probably heard this before, but maybe you forget your dog's name is Cody too? Aww. I do remember when I got the dog and named him, I had some student named Cody, and I'm like, I promise you I wasn't naming him after you. Anyway, first rule of factoring. You are looking for common factors of all terms, things that will divide everybody. So I'm going to come back over here and let's start factoring. For number 3, do you see that as far as the x to the powers are concerned, both terms can be divided by x to the power of 3. So that means that I can factor out x to the third power. When you're factoring, you're technically dividing. So you're looking at what is 4x to the fourth divided by x to the third power, and hopefully you see that is 4x, right? Minus, and then what is left when I divide x cubed by x cubed? 1. Now, if you manage to take a common factor and it's just a single term, x cubed is just a single term, one factor, set it aside, you are done with that as far as factoring is concerned. Then you want to look at what's left in the parentheses. If you have a linear polynomial, you can't factor any further. But if you have something of a larger degree, then it is highly likely that you can factor it. And in this class, you're just going to get the nice version of polynomials. You're not going to get the ones where there are issues where you have quadratics that can't factor. 4x to the fifth? I'm not sure what you're saying. Anyway, if I see something, I'll look at it. For number 4, what if you were left with like just 4x to the fifth power, then you actually only have one term to begin with. Because what the factoring that we're doing here is over an addition or a subtraction sign, dividing each of those terms by something, so you're left with an addition subtraction sign. When you factor out what's common, in that parentheses, you have the same number of terms as the polynomial you just factored. So with number four has 3 terms. So if I can find something that will factor out of all of them, I will have 3 terms left. So let's take a look. Do you see something that will divide all 3 of these? And I'm looking at chat. Do you see something that will divide all 3 of them? And by that, do you mean x squared? X squared can divide all 3 of these terms. So when you have a polynomial where every single term has x, you're going to take the smallest number exponent, and that's what you can factor out. Now, it would be nice to factor more than that out, but if I do, I'm going to end up in a fraction world, and I like to stay out of fraction land. It's not my favorite place to be. So now I have, when I factor it, I have x squared times, and then each term is divided by x squared. So what is x to the 4th divided by x squared? X squared minus, what is x cubed divided by x squared? X, plus 20x squared divided by x squared, 20. You got it. So I was able to factor out a term, its aside, look in the parentheses with what is left over. Can that be factored? And now the smile should come on your face, sarcasm spilling out of me. X can be 1. Oh, x can be a factor, you mean? Like in number 3. This x, or do you mean exponent 1? If you have exponent 1 and that's it, and it's linear, you're done. But now I have a quadratic to deal with, but it's a nice one. 2 numbers, you multiply, you get positive 20, you add, you get negative 1. So plus, or so I can do plus 4 minus 5. No, wait. No, I can't. Hold on. Sorry. Brain went. Wait. Hold on a second. I think I may have typed that wrong. Are there 2 numbers that when you multiply them, you get 20, and when you add them, you get negative 1? No, there are not. I typed it wrong. So what I need you to do is correct this, and I need to remember to correct the documents. This should have been a minus because, well, you know what? Hey, tell you what. With it being the way it is, you couldn't have factored it further. But I'm not planning on taking you through that. This should have been minus 20, not plus 20. That was bad because that didn't make sense. So minus 5 plus 4 was what I recall I was going with, and then messed up with that negative. So with that changed, this would be correct. And in fact, I can double check that that's what I was thinking if I look at the answers I made. What? Oh, there. Oh, you silly girl. Silly, silly, silly. All right. I'm going to forgive myself and move on. Number 5. What can I divide both terms by? I can divide both terms by x. If I divide x cubed by x, I will have x squared. Then minus, when I divide 9x by x, I get 9. So what I was able to factor out as a single term, that's done with the factoring. I'm left with something quadratic. And is that something that you recall how to factor? Oh, yeah, sucks. So, right, this is a difference of squares. So you end up getting a pair of conjugates. If I have used that word with you before, the factors are identical, but one's addition, one is subtraction. And now I have, there are actually 3 linear factors. All right, we're going to keep going. Next, is there anything that I can factor and divide all terms by? And it's time to get happy. You're getting happy because the leading coefficient, nobody ever likes to factor when you have a leading coefficient that isn't just a 1. I can divide by 2 and have something that is nicer to factor than what it first looked like. 5 minutes left. So 2x squared divided by 2, 4x divided by 2, and 30 divided by 2. And how does what's left factor? How does what's left factor? X plus 5, x minus 3. And then that is as factored as you can get. And I think this was my last one. Yes, last one. Okay. What can all 3 terms be divided by? You got it, 5x. So when I divide this first term by 5x, what is left? And I'm assuming someone is trying to type it right now. 2x squared. And then what's left if I divide 5x squared by 5x? And what am I left with on this last term when I divide by 5x? There we go. Now, what I set aside is a single term. It's taken care of, but I still keep it around. But what is left from factoring that out can be factored further. And this is the slightly harder factoring because you have a non-1 leading coefficient there. Oh, good, good, good. So 2x plus 1 and x minus 1. And you can double check that that's correct by going, what is 2x plus 1 multiplied by x minus 1? And then going, hey, that's 2x squared minus 2x plus x minus 1. And when I add them together, I get that. Yay! So that is completely factored. Now, you have dealt with quadratics and graphing parabolas. Polynomials, that's like their baby. And with polynomials, our bigger concern are polynomials that are higher than degree 2. You've been working with degree 2, you've been working with lines. Now it's time to work with higher degree polynomials. And with that comes factoring, but the factoring will remain relatively decent. I'm not going to send your way the worst factoring things ever. And to be honest, going up too high in degree becomes cruel. And so we'll be looking at a lot of things, but I'm not going to make it overly tedious. You might see that there could be some tedious, there could be, but I'm keeping it on the low side with tedium. Anyway, we've got less than a minute left in class. So I'm going to stop recording. And